Sometimes when you're writing a loop, you'll find yourself in a situation where you think to yourself, I'm done for this time through the loop. I just want to go back up to the top and come through again. I don't want to do any more statements this time around through the loop. The continue statement lets you do exactly that. Here's my standard picture for a loop, and as before, I don't care if it's a for loop or a while loop. Continue works exactly the same way for both of them. So let's just get rid of the words, and this is a loop. The single word statement continue says, just stop now and go to the top of the loop. When we reach the top of the loop, we proceed just as if we had got there by normally getting to the bottom of the loop and then coming all the way up to the top. If it's a while, we do the test. If it's a for loop, we do the update and then the test. Processing doesn't care. It just says, oh, here I am suddenly at the top of the loop. I will proceed as before. The idea is that if you have lots of statements after continue that you've decided you don't need to execute this time through the loop, you can just skip them altogether. Of course, you could just wrap them all up in a big if statement and get the very same results, and we'll see that. The value of continue is it lets you explicitly state that that's what you're trying to do. Continue says to you as a reader of the code, hey, I'm going back up to the top. And sometimes it's easier to think of your code and design it and write it using a statement like continue. Let's see an example of this. I'm going to use the same example that we used for break. I'm going to draw a long row of circles on the screen, and I'm going to use a loop to draw them. In the break example, we drew just a single line, and we stopped drawing circles when we reached the line. For this example, I'm going to have a box, and any circles that are inside the box don't get drawn. It doesn't matter where the box is, and I can use my mouse to move the box around. Any circles that are within the box don't get drawn. So how are we going to do this? As always, let's label everything in sight. I'm going to call the left and right sides of the box ML and MR. If I was writing this from scratch, I would call them box left and box right, probably. But again, I'm trying to keep everything super short for these examples, and because I'm adapting the code that I used for break, where this was called MX, well, it seemed reasonable to call this ML and MR. And the radius of the circle, as before, is CR. Notice that these are all global variables, and that's going to be helpful to us in a little bit. Finally, as we draw the circles left to right, the variable xpos tells us the location of the circle we're about to draw. So let's write the loop to draw all of these circles, and it looks just the same as the loop we saw in the example for break, so I won't go through it in detail, but just reading it from the top quickly, we create xpos and set it to 0, that's the location of our circle, and now we have a while test. I'm testing xpos minus cr against width. Xpos minus cr is the left side of the circle. If you look at the drawing, xpos is the middle of the circle, cr is the radius, so xpos minus cr is the left side. By testing if that's less than width, I'm effectively asking processing, is any part of this circle visible? Because I'm drawing left to right, as soon as the left part of the circle falls off the right-hand side of the screen, I know I'm done drawing. So that's my test in while. You can see we have an if statement, and I'm going to fill that in with something in a moment. If the if statement is true, we draw the ellipse. Then we add to xpos and go back up to the top of the loop. So the question is, what goes into that if test? When the if is true, that's when we draw the ellipses. So what we want to know is, are we inside the box or not? If we can somehow devise a test that gives us true or false to tell us if xpos is within the box or not, then we can use that true or false as our test. So let's leave this code aside just for a moment and see if we can come up with that test. I'll tell you how I come up with these sorts of things, which is I grab some scratch paper and a pencil and I doodle a little bit. And I find a way of thinking about the problem that makes sense to me. There are lots of ways to come up with a test that will tell you if a given circle is within the left and right sides of this box. And if you like a little puzzle, you might want to stop the video right now and work that out for yourself. I'll show you just one way. This is the way I went about it. Since this is a video on continue and not on figuring out if circles are inside boxes. I'll just go over this very quickly, but if it doesn't track for you, sit down with a piece of paper and a pencil and you'll see all of this works out. Here's a simplified version of the diagram where I've marked the two circles that are inside the box. And we ask, what is true of those? Well, with respect to the left-hand side of the box, they're to the right of that. So we can write this test this way. We can ask if the right-hand side of each circle is to the right of the left side of the box. In the same way, we can look at the right side of the box and we can see that those circles are to the left of the right side of the box. And we can write the condition this way, asking, is the left edge of the circle to the left of the right side of the box? We can find the circles that are inside the box because those are the ones for which both of these conditions are true. We can combine these with the Boolean operation AND. Here are the two tests joined together with an AND. That's two ampersands. This whole thing is true if the left side is true and the right-hand side is true. That is, if we're inside the box. Now there's a lot of parentheses and greater thans and plus signs and stuff in here, so let's package this up into a little routine that I'll call inbox. It returns true or false, depending on whether the variable it's passed, x, is the center of a circle that's inside the box or not. We can just take the test we wrote and return that. It'll be true or false. The one thing we have to fix up is notice that in the code now I'm using xpos, but the variable that the routine is passed is called x. So let's get rid of the other stuff so we can focus on what's going on. Let's take these two instances of xpos and replace them with x, because that's the variable that's being handed to the routine. So great, now we have a little Boolean routine. We hand it an x value and it comes back with true or false, telling us whether we're in the box or not. Let's go back to our code and stick inbox in the test. And now we're done, right? Well, we're not because we have it backwards. Take a look at the if test. It's saying if we're inside the box, draw the ellipse. But we want the reverse of that. We want if we're not inside the box, then draw the ellipse. The picture we want is this picture, the opposite of the previous one. You may remember that that's what the bang does for us, the exclamation point. It turns true into false and false into true. So I'll open up a little bit of space in the if statement and I will stick in a bang. Now what that if statement says is if we are not in the box, draw the ellipse. And that's just what we're after. This code will create this picture. Let's see it in action. Here's the program running, and you can see we're not drawing any of the circles inside the box. I can use my mouse and drag around the right side or the left side of the box, and I can move it around pretty quickly, and we are just not drawing any circles that are inside the box. So this is working great. Let's see now how to do this with continue. Continue gives us a different way of accomplishing the same ends. First, I'm going to highlight these two clusters of code and I'm going to switch them. I'm going to move xpos first and then test if I'm going to draw it. That's just going to make it easier to show you how continue works. But now I have a little problem. The first line of our code sets xpos to 0, but now I'm adding 2.5 times CR to xpos before I draw the first ellipse, which means I've basically jumped over the very first circle. So I'll fix that by going back up to the top line and taking out the very amount I'm going to add in. Now, my first time through the loop, when I add 2.5 times CR to xpos, xpos will be 0. So now xpos is working properly. What I'd like to do is to show you how to use continue. I'm going to keep the if test, but I'm not going to use it to test if I want to draw an ellipse. So tell you what, let's back off the ellipse and get rid of the braces. I'm still using bang inbox, and I'm going to change that. I'm just going to use inbox. So now my test says if we are in the box, then do what's going to be in yellow, and you know what that's going to be. It's continue. So the idea now says each time through the loop, we test the circle before we draw it. If we are in the box, then we execute the word continue. And continue says, jump back up to the top of the loop. That means we don't execute anything else throughout the rest of the loop all the way down to the closed curly brace. In this case, there's just one line, and that's the line to draw the ellipse. So as soon as it hits continue, it just jumps right back up to the while, and the ellipse never happens. Let's see how this runs. Here's the same program, and I just changed the while loop to reflect the code we just wrote. I'll drag around the right-hand side of the box, and I'll drag around the left-hand side of the box, and you can see it still works just as well. And of course it should. We've merely found a different way to state the same goal. Let's compare these two. Here's the if version. We have the while loop, and inside the while loop, we test every time. And we say if we're not in the box, then we draw the circle. Here's the continue version. Now, every time through the loop, we test to see if we are in the box. If we are, we execute continue, which jumps us back up to the top of the loop. Both of these accomplish the same ends. Which version you choose to write is strictly a matter of style and preference. They're both great approaches, and you'll see both of these in other people's code. So continue is very simple. It just says, when you execute me, I jump back up to the top of the loop right away. And that's all there is to continue.